Swayam Prabha. Digital India. Educated India.
We discussed on, in the last lecture we talked about self compacting concrete. We will continue with that today, but at the end we will also introduce fiber concrete. So, outline of today's lecture would be some tests for self compacting concrete, its use, advantages, and then we will have introduction to fiber concrete. Just to remember what we did in the last discussion, last lecture, we said that water to powder ratio should be 0.8 to 1.1 by volume, something of that order. Total powder content ranges from about 400 kg per meter cube to 600 kg per meter cube. Powder, remember, powder means cement plus even fly ash or any other inert material. So, all that constitute powder. Coarse aggregate content 28 to 35% of the mixed volume, and water content less than 200 kg per cubic meter. Fine aggregate content, it is generally higher in this one, 48 to 55% of total aggregate, and this was possible because of very high range or ultra high range water reducing agent. And this is, if you look at the plasticizers 1960, super plasticizer, basically sulfonated melamine formaldehyde and sulfonated naphthalene formaldehyde. They are actually 1970s, and then polycarboxylate ether, that was 80s and 90s. Some modification of this one through polymer modification in between, all that occurred, and all this led to our honeycomb structure that could be formed, obtained from this polycarboxylate ether type, and this is what led to actually SCC. This is what led to SCC. This arrow shows this was led to SCC. So, this is the honeycomb structure, and we know that for this one, this because of the steric stabilization, it could actually disperse the cement grain more, and that is what resulted in this kind of concrete, that is self compacting concrete, self compacting concrete. So, this is what has caused this. We discussed earlier how the what is steric stabilization and the kind of PC, how do they work. This we have discussed when we talked of chemical admixtures to concrete. We are just reiterating the same thing a little bit more, and historically this has led to self compacting concrete. So, that is what we are saying, that it led to self concrete. And if you look at the rheology, plastic viscosity along this direction, yield shear stress along this direction, and you know the Newtonian fluid will go somewhere there, Newtonian fluid will go somewhere there, all right. This will be a linear line with yield shear stress being 0. So, flowing concrete should have lot of very low, flowing concrete will have very low yield shear stress, flowing concrete. Normal concrete lies somewhere there with some amount of yield shear stress and the viscosity being there somewhere, right. So, normal concrete will lie somewhere there. High strength concrete, they have more paste, remember, and therefore, they change the like the yield shear stress might be somewhere there to yield some of this range, right, depending upon of course their flow properties, and viscosity ranges varying from this to this. So, this is high strength concrete because their paste content is more, and pumping concrete should have low viscosity, low yield shear stress, and viscosity should be somewhere there, right. Now, why the yield shear stress is, it can withstand some amount of yield shear stress. How? Because it can yield some amount of yield shear stress, because you will be pumping them. So, there is a pumping pressure, only thing it should remain cohesive and should not segregate. Internal pressure, disturb relative motion between particles should not be there within it, but must form a plug and then move. So, that is pumpable concrete. Or now self compacting concrete is somewhere here, flowing concrete. So, very little yield shear stress and viscosity ranges from here to there. So, viscosity ranges from here to there. So, that is where in the rheological scenario self compacting concrete's location is somewhere there, should have very little yield shear stress, should flow straight away. So, that is what is self compacting concrete. So, it lies here somewhere, it lies here somewhere, all right. So, the test meant for self compacting concrete. So, we actually looked into all the principles of self compacting concrete, what it is, why it becomes self compacting, etc., in the last lecture, and then continued a little bit now, and now we can look into the test methods meant for self compacting concrete. Obviously, since it is flowing, highly flowing, does not require any compaction. So, we can't use the conventional slump test or compaction factor test. Compaction factor will be nearly 1, practically no variation, because it will just fill in, and obviously we can't use VB test, which is meant for stiff concrete. So, this is actually VB time will be 0 in all the cases. So, therefore, you have to devise new test for this one. Several tests have been devised, there are a large number of them, and some of them have been codified in some codes, but it is still to be universally accepted single or 2 tests which would be suitable for self compacting concrete, its property, to at least define it as a self compacting one. There is no single test, or currently there are a large number of tests, and they are getting gradually codified. You remember the requirement of self compacting concrete. We said it should have filling ability, passing ability, flowability, and remain cohesive, and so on and so forth, segregation resistance, several properties we talked about. Now, there cannot be any single test by which I can determine all those requirements or all those properties. So, how do I measure, for example, resistance to segregation? And quantification is, of course, still far cry. So, at the moment there is no quantification, but some empirical tests are being devised, and we will discuss some of them. So, one of the tests is U-tube test. This test is effective only in judging whether or not the concrete has sufficient compactability. Will it compact itself? It will not be able to judge the flowability to a great extent, or other requirements, segregation resistance. So, it will not be able to judge the segregation resistance and such thing. If the concrete does not have sufficient self compactability, we have to detect the cause, of course, and the mix proportion has to be adjusted. I mean, there should not be any void in the system, it should compact on its own. So, this looks for self compactability. How does it look? I have actually a U-tube separated by a barrier, kind of a barrier, separated by a barrier, all right. So, this is the U-tube, this is the U-tube, and then there is this is a partition, and there is a barrier. Now, this is actually a gate which I can open. So, I fill in the concrete here first. Dimensions are of the order of around whatever is given, 660 mm and so on, 260 mm and those kind of thing. Dimensions are by and large given, 280 mm dimensions are given by and large, the dimensions has to fit in. So, this 280 mm, 680 mm and so on and so forth, and there is a gate which I can open. So, I fill in the concrete here, the obstacle, and this place there is a gate obstacle also. the rebars are there, reinforcement bars are there, the spacing between the reinforcements are there, they are actually 16 mm bars and the obstacles are there. So, what you do is followed from this, I just lift this up and allow the concrete to move from here, allow the concrete to move from here. Now, if it is self compacting, then this height should be same. So, if this is not flowing due to low flowability, if it is not flowing and it is because of the segregation, then it cannot be self compacting. So, this is too stiff mix, it is a stiff mix, does not move at all, does not move at all, very stiff due to low flowability, it is a stiff mix, not self compacting. So, the stiff mix it does not move at all, only little bit it moves, and actually it is too flowable, that means might cause segregation, water might have moved, but the solid might have got stuck here, solid might have got stuck here and thereby resulting in higher densities of the solid at this place, and only water flowing down there, solid remaining sort of kind of accumulating here, and therefore, it is not self compacting, therefore, it is not self compacting. A self compacting one will have water, of course, if I put it, they will have, it will just have two equal heights, but this is not water, but it should be sufficiently close to each other, sufficiently close to each other. So, this is called U tube test. So, this test gives us self compactability, but slump flow gives us fluidity and deformability. So, two other tests, one is a slump flow test, other is a funnel test, have been proposed for testing deformability and viscosity respectively. So, therefore, fluidity is determined by slump flow. The criteria to satisfy self compacting concrete by slump flow test should be 64 to 75 centimeter slump flow. IS 456 200 456 2000 of course defines 600 mm minimum flow to satisfy it as a self compacting concrete, right. So, this is actually determines fluidity. Now, how does it do it? I will come to this. This is your slump cone and these are the marking, this is about 500 mm, and then if you fill it in the standard manner, and as you fill it in, lift it up, it should get spreaded like this, measure the spread, measure this spread. So, this spread is a slump flow and this flow minimum should be 64 to 75 centimeter, from 20 centimeter to it should go to about 64 to 75 centimeter. IS 456 says minimum it should be 60 centimeter or 600 millimeter to define it as a self compacting. So, minimum for self compacting concrete is given. But if it is less than 64 centimeter, then it is highly viscous concrete, and if the spread is less lower down, that means approaching normal concrete. So, spread should be sufficiently large. So, therefore, its viscosity is high, viscosity has a tendency, if it is lot of resistance, then it will not flow. So, it is somewhat measured, it is related to fluidity of the system, fluidity of the system. So, that is what it is, the slump flow test, and this is very popular because it is an easy test. B funnel test, it gives direct measure of viscosity, sort of it gives some direct measure of viscosity, that is what is people felt, and you have a funnel which is closed at the bottom in the beginning and open the gate at the bottom, fill it in a standard manner, then the time is measured for discharge of the concrete through the bottom opening, which is now initially closed, and then it comes down here, and if this time is 10 seconds, 10 plus minus 3 seconds, then you can say it could be self compacting. So, basically you determine the fluidity and this determines viscosity. So, this determines a measure of viscosity, this is a measure of viscosity. So, higher flow means what? I mean, if it takes longer time, that means a stiff concrete does not have flowability is not proper, because it is flowing through that bottom opening. So, kind of viscosities would dominate. So, if you have too much of friction or viscous resistance, then it will take longer time, and if it takes too less time, maybe this it might have a segregation tendency. So, therefore, that is why it is 10 plus minus 3 seconds time. That is what is V funnel test. Now, segregation resistance is measured by L box test. This is segregation resistance measured by L box test. The vertical part of the box is filled with concrete, which is left to rest for 1 minute. During this time, the concrete will display whether it is stable or whether there is segregation. That means, when you keep it 1 minute in a vertical part of the L box, which we will see just now, if you leave it for some time, if there is too much of water segregation, it will come up. So, if it is not segregating, then you open the gate, as we shall see that, you open the gate as we shall see that, right. So, it will look like this. So, this is the L box. So, you fill it, there is a gate here, you close it, there are obstacles here, bars here. So, gate remains closed and fill in the concrete in a standard manner, be there, keep it there for 1 minute or so, and if there is no segregation, then you allow it to pass through, you can judge whether segregation or not, then open the gate, it will pass through this obstacle and fill in the concrete at this portion, it will fill in the concrete here. So, it will look something like this, through the obstacle it will pass. 200 mm is the width of this one, these obstacles are 12 mm bars at 46 mm spacing, as a rate of 46 mm center to center spacing, and as it pass, the concrete here would be like this, and this height we call it as H2, this is H1, this dimension is 760 mm, this is 600 mm and so on so forth, and this is 150 mm. So, allow it to pass through it, and if this two H2 and H2 by H1 is equals to 1, then it is perfectly self compacting. The water would actually make these two height same, but for self compacting concrete, this should have a minimum ratio, that ratio is 0.8. So, that ratio is 0.8, that ratio is 0.8. So, it should be at least 0.8, at least 0.8. So, it should satisfy the criteria, satisfies SCC should be H2 by H1 should be at least 8. If it is 1, that is very good. So, it should be 0.8, it should be 0.8, it should be 0.8. So, that is what it is. So, this is another test. So, you can see there are several tests so far we have looked into, and there are more tests actually. For example, sieve segregation test. Now, the problem is we are yet to actually we are yet to find out first of all the criteria, right, like we said, filling ability, passing ability, compactability, segregation resistance, fluidity, all this, there are several requirements. So, if you could, how do you quantify this requirement? Actually, to quantify the requirement, some sort of test should be devised, all right, but then they are not all independent, because if you have high fluidity, maybe that will help in compactability. If you have for example, passing ability, that might have again related to flowability. So, there at the moment there is a kind of no uniformity. You see, when you are very confident about certain things, when understanding has grown very well, you need only one test or maybe one parameter to define everything, one model at least to define everything. But here the confidence is yet to build up on the understanding, and a single test cannot, right now there is no single test. So, there are several tests, as I said, suggested by different people, and finally possibly over the years it will come into a kind of now less, it will get reduced down somewhat. If one wants to look from fundamentals like Bingham's model, then this should have been Bingham's model, then this should have been the gamma yield shear stress and the viscosity, you call it nu or mu or whatever it is, you call it mu. So, this could have, viscosity should have been sufficient, but at the moment this is not really happening that way. for example, we said that gamma versus viscosity, if you plot it somewhere here it should lie. So, if there is no way to measure gamma, I mean there is no I will say not really no way, there is no universally accepted method to measure gamma or mu, the rheological properties. But supposing we could have done this, we would have said that for being self compacting, only one measurement, the rheological measurement determine gamma as well as mu, and you say if the gamma and mu ranges between this range, gamma should range from 0 to something, mu should range from this to this, then I will call it self compacting. But at the moment we are not at that stage. The way to measure this self compactability is still not really universally acceptable, and neither the rheological properties, no universally accepted method for measuring rheological properties. I mean rotation viscous meters are there, which we talked about the tau versus RPM, etc., remember we showed some graph earlier when we were talking about rheological properties. So, these viscometers themselves are not really so far universally acceptable. All right. So, therefore, we have large number of tests. So, we have one more test, that is sieve segregation test. Now, this test, it measures segregation resistance. Now, what you do? You allow the concrete to stand in a bucket for 15 minutes. 4 2 dimensions of this system will be fixed actually. Pour top 2 liter on the sieve of 4.75 centimeter, 4.75 millimeter, it can't be centimeter, 4.75 millimeter, 4.75 millimeter, 4 centimeters will be this, 4.75 millimeter, sand size, it is a sand size, that is a mistake. So, with a pan below, ratio of the mass passing to poured mass is a measure of segregation resistance. So, what you do? You take the top 2 liter from a bucket, put it onto the sieve, and the amount passing through that sieve is a measure of segregation resistance, because you have kept it for 15 minutes. Now, if there were segregation, for example, if the water is coming out and the solids or larger particles etc., go down below, then actually quantity passing through this sieve will be very large. So, if the solid, even the finer solid is separating out along with water, it is taking out the finer material too much, then passing through 4.75 mm sieve, most of it will pass through. So, the quantity that is passing is a measure, quantity or proportion of the mass passing is a measure of segregation resistance. If it is less, that means the relative proportions of the fines water to the total mass, that would be, that should be appropriate. So, you can actually relate this to the segregation resistance. So, one can relate this to the segregation resistance, 5 to 15% is considered satisfactory. Less than 5% is high resistance to segregation, because nothing is passing, and more than 50% is possibility of segregation. So, less passes through it. First of all, you have separated out, taking only top 2 liters from the top. So, if it contains a lot of fines, and not larger material, but supposing it is not segregating, larger materials also will be here. So, if you take the top 2 liters, larger material, so it is not segregating it, right, resistance to segregation. So, high segregation resistance might reduce down the flow, that is why less than 5% may not be desirable, but if more than 15% is passing, that means it contains mostly the fines, and therefore, majority is passing through it. So, therefore, this is a measure of segregation resistance, this is a measure of segregation resistance, this is a measure of segregation resistance. Then this is another test, T50 test. I already talked about L box test. Okay, some more tests we will talk about. T50 test is time for 50 centimeter slump flow. So, you find out, measure that, measure flow as against time, measure flow against some flow against time, with time how slump flow is changing. So, time at which 50 centimeters slump flow occurs, that is T50 test. So, that gives you T50 test. So, that is again, that is a measure of slump, in a way slump retention, it will be a slump retention or related to, it is another test actually. J ring test is slump flow with a ring obstacle. So, you have the same slump flow, but there is an obstacle, there is an obstacle, there is an obstacle, there is an obstacle. So, there will be obstacle here. So, it is a J ring test. Slump flow ring obstacle provides information of passing ability. So, whether while flowing, it is actually trying to combine the fluidity with passing ability. It is trying to combine the fluidity with passing ability. So, then you can find out the flow. After putting the obstacle, what is the flow? So, that would be a kind of measure of fluidity plus passing ability. Fill box test, that is again a box in which concrete is filled in first, then it is allowed to